Okay, here the recording in progress. So let me share the screen. All right, so we're starting 10.4 today. And we have 10.4 and 10.5 left before the exam next Friday. So schedule-wise, we are here. Okay, so just about right on schedule. So 2 days for 10.4, 2 days for 10.5, maybe an extra day as needed for a buffer day and questions and answers. And the next exam is Friday the 29th. Okay, and after that, we quote unquote only have one more chapter, but it's the longest chapter. As you can see, it's on sequences and series. Okay, so first thing I'm going to do is give you the quiz now. So I'll be ready if you wish to take a picture on your cell phone or do a screenshot, you may, or you can just watch the video later on this. All right, and here we go. So number one, find an equation of the tangent to the curve defined parametrically by x equals 1 plus radical t, y equals e to the t squared at the point 2e. So you had a problem sort of like that. On the homework, I'll just give you some hints. You need to find dy dx, and there's a formula for dy dx, right? And you're given a point, you do have to find the t value. That shouldn't be that hard to figure out what t value works. And then you go from there, okay? Spend a little bit more time on number two, the harder one. Make an appropriate table and sketch the polar graph of r equals 3 sine 4 theta. Okay, so I mentioned I give you a 4 theta problem and use only the graph paper that I mentioned in class from mathbits.com. Make your graph an appropriate size. Okay, so I sent this out on Monday, I believe, on Canvas announcements, the mathbits.com graph paper, right? So use just that graph paper, don't use anything else, one of these things. Okay, and I'll talk a little bit more about this. So this is long. I would never give you a problem like this for the exam, but since you have a lot of time to do this on a quiz, do 11:59 p.m., I'm willing to give you something like this on a quiz. Okay, so 4 theta. Okay, first thing, you should be able to tell what the maximum value of r is, and I showed you how to tackle that. Keep in mind you have 14 concentric circles, right? And we did problems involving maximum value. So if you make your graph too small, I might take off points, and you want to spread things out so that it takes up as much of the graph as possible, right? Okay, so 4 theta, as I mentioned yesterday, your table has to be 4 times as big as normal. If you want to look at what we did for 3 theta, and you have to go out to 4 theta. Okay, now, our table normally went out to 45 degrees. Okay, you have to chop that into 4. Okay, now I did a 2 theta one. 2 theta one, if I can kind of cover this up, I went pi over 8 and 22.5 degrees, right? For 3 theta, it was convenient because it was already chopped into 3. You had 15 degrees, 30 degrees, 45 degrees. For 4 theta, unfortunately, you have to do more work. So pi over 8, 22.5 degrees. Okay, as I said, you have to chop these in half. So half of pi over 8 is pi over 16, which is 11.25 degrees. And pi over 16, 2 pi over 16, 3 pi over 16, 33.75 degrees. And 4 pi over 16, pi over 4. Okay, we're going to do this all the way around the circle. So here I did it from 0 to 45 degrees. Do the same thing from 45 to 90 and all the way around the circle. Your table is going to be 4 times as long as usual. Okay. Again, I highly, highly suggest that you do the divide and conquer method I taught you, just cut and paste, as it were. Again, if you do it the right way, you only need to do the calculations from 0 to pi over 2, because from pi over 2 to pi, just copy and paste. From pi to 3 pi over 2, copy and paste. 3 pi over 2 to 2 pi, copy and paste, and then go from there. Okay, so you'll definitely need something like this all the way around the circle. I've just done from 0 to 45 degrees. So you need a marking every pi over 16 or 11.25 degrees. Okay, So that is that. So do it 11:59 p.m. It is long. I admit it's long. I would never give you that for a 15-minute exam, but for a quiz, which is not due until 11:59 p.m., I don't mind giving that to you. Okay. So that is that. And now we will go on to the new material. Okay, so 10.4. Areas and polar coordinates. Put this on your cheat sheet. Area is the integral from A to B of 1/2 r squared d theta. Generally, the 1/2 just comes out. You square the original r function, and then you integrate. So we're going from two angles, one angle to another angle. So here we're integrating from negative pi over 4 to pi over 4, for instance. Okay. So here we go. Okay, number 1, r equals e to the negative theta over 4 between pi over 2 and pi. Okay, find the area bounded by the graph, and theta is pi over 2 and theta is pi. So 1/2 r squared d theta is a formula. Normally take out the half. E to the negative theta over 4 squared becomes e to the negative half theta. Okay, so the integral is the same thing, e to the negative a half, and chain rule in reverse. If I were differentiating, I multiply by negative a half. Since I'm integrating, I divide by negative a half, which is the same thing as multiplying by negative 2. And very conveniently, this negative 2 cancels that 2, so I have a negative in front of the whole thing. Plug in pi, I have e to the negative pi over 2. Plug in pi over 2, I have e to the negative pi over 4. And the best way to rewrite this is to turn this around. So e to the negative pi over 4 minus e to the negative pi over 2. And that's my answer for the area. Here. Okay. Then the next one, I didn't even label the number for that one. From 0 to 2 pi. This is not even here. So I should have labeled it. So let me call this 3 star. Okay. So the function was r equals radical theta between 0 and 2 pi, which incidentally is also spiral shaped. So if you were to graph it, it also looks something like this. Okay, so we're finding this area. It's quite amazing that we can find areas of something weird shape like that. But we have a nice formula. So it's 1/2 r squared d theta from 0 to 2 pi. Half comes out. Radical theta squared is just theta. So I'm integrating theta. That's theta squared over 2 from 0 to 2 pi. Plug in 0, you get 0. Plug in 2 pi, I messed up here. It's 1/4 of 4 pi squared minus nothing. So the answer is pi squared. Okay, number 5, I'll give you this picture. R squared equals sine of 2 theta. Looks like we're just in the first quadrant. Okay. So we start at 0. We come back to the pole, looks like at pi over 2. This angle here. So I integrate 1/2 r squared d theta. They already gave me r squared. I mean, you can write r as the square root of this, but why bother? The formula says r squared. Here is r squared already. All right, so the integral of sine of 2 theta is 1/2 cosine 2 theta from 0 to pi over 2. So that gives me negative 1/4 cosine of, plug in pi over 2, I have the cosine of pi minus the cosine of 0. So that's negative 1/4. Cosine of pi is negative 1 minus the cosine of 0 is 1. So it's negative 1/4 times negative 2, which comes out to be 2/4 or 1/2. So the answer is 1/2. Interesting side note, it's kind of amazing that this weird shape should have such a nice area, right? I mean, I would not think this to be a nice number or be irrational, and yet it's exactly 1/2. Okay, so we're using the formula 1/2 r squared d theta, that's what we integrate. Okay, it's on page 670. Okay, so put that thing on your formula sheet. Okay, now we have a few set of problems where we have to sketch and find the area. So like number 9, sketch the curve and find the area that it encloses. Okay, or 17, find the area enclosed by one loop of the curve. Okay, so how do you do that? So that's going to require the graph paper also. And we'll figure out what's going on. So number 9, r equals 2 sine theta. All right, so the maximum r is 2 because sine is between -1 and 1. And by the way, that should be a big hint for the quiz also. Right, maximum is 2. We have 14 circles, so we did r equals 2 as the greatest possibility. We'll go the 10th circle. So I will waste circles 11, 12, 13, and 14. That's okay. Again, should I go all the way out to the 14th circle? I think that's very awkward because that means r equals 1 is 7. It's very hard to work with 7. That means each circle is 1/7, 1/7, 2/7, 3/7, 4/7. That's not very comfortable. So we'll just make this the 10th circle, which means r equals 1 is 5 circles, and any one circle is 0.2. So that's 0.2, 0.4, 0.6, 0.81, 1.2, 1.4, 1.6, 1.8, and 2. All right, r equals 2 sine theta. I don't have a coefficient in front of the theta, which means I can just go every 45 degrees. So 0, pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5, 6, 7, 8. Excuse me. Okay, divide and conquer. Plug in 0, sine of 0 is 0. Okay, if I plug in 2 pi, I also get 0. Cut that in half. Pi, sine of pi is also 0. Cut those in half. Pi over 2, 3 pi over 2. Sine of pi over 2 is 1, times 2 is 2. Sine of 3 pi over 2, -1, times 2 is -2. And then if you cut those in half, they're all going to be either radical 2 over 2 or negative radical 2 over 2. Sine of pi over 4, sine of 45 degrees is radical 2 over 2. 2 times that is radical 2 to about 1.4. So I'm going to write either 1.4 or -1.4. From here on out, you don't even need a calculator. Just look at it logically. I'm going from 0 to 2. Is it going to be 1.4 or -1.4? 1.4. Okay, I'm going from 2 to 0. 1.4. I'm going from 0 to -2. -1.4. I'm going from -2 to 0. -1.4. Okay, and a quick graph. 0, 0, origin or pole. 45 degrees, 1.4, which is the 7th circle, because 0.2 is 1. So there's 1, 1, 2, 3, 4, 5, 6, 7. It's there. Pi over 2, I'm at 2, maximum r. And then 3 pi over 4, I'm back to 1.4. And then pi, I'm back at the pole. Okay. In case you're wondering, yes, it is a circle. If you were to plot more points, it is circular. And so where's the rest of the graph? 5 pi over 4, I'm aiming here, -1.4. I already got that point. So once again, we have a repetition. 3 pi over 2, I aim down, I back up 2, I get that point again. 7 pi over 4, -1.4. So 7 pi over 4, I walk backwards. And then 2 pi, I come back into the pole again. So from 0 to 2 pi, this graph actually gets traced twice. Therefore, when I do the area, I'm only integrating from 0 to pi. That's a key point here. You do not go from 0 to 2 pi because that traced the circle twice. Right, so I only have to integrate from 0 to pi of 1/2 r squared d theta. Okay, that's 1/2 of 4, which is 2. Take the 2 out. I have integral of sine squared theta. By formula, sine squared theta is 1 minus cosine 2 theta over 2. Put that in your cheat sheet if you need to. Very convenient, 2's cancel out. Integral of 1 d theta is theta. Integral of negative cosine 2 theta is negative 1/2 sine 2 theta. Again, chain rule in reverse. If you differentiate right here, you will multiply by 2. So when you integrate, you divide by 2 and multiply by half. From 0 to pi, plug in 0, you get 0. Sine of 0 is 0. Plug in pi, sine of 2 pi is also 0. So the only thing of substance is right here, pi. That happens a lot when you do this integral. So the answer is pi. All right, and a little bit of double checking here. We know that this is a circle. So this circle has a radius of 1. The center is not at the origin. The center is here, 1 unit up. Okay, and we know the formula for the area of a circle is pi r squared. So the area is pi times r squared, pi times 1 squared, which is pi. And that confirms what we have over here. Okay, so the key thing for this is not to go from 0 to 2 pi because of the way it was traced. The entire circle got traced just from 0 to pi. So if you went from 0 to 2 pi, you get twice as much area. So you would end up with 2 pi, which is the incorrect answer. Okay, so this one had a lot going on. First, you have to draw the graph to see what's going on. And then based on that, use the formula 1/2 r squared d theta. And we'll show you setup for 17. Okay, this one, I'm not going to do an entire graph. Find the area of the region enclosed by one loop of the curve. So I only want one loop. R equals 4 cosine 3 theta. Now, since they only want one loop, all I need to do is establish one loop. So I don't need to use up one of my graph papers for this. Besides, my table would have to be 3 times as big, right? I showed you a 3 theta case. Look back in your notes for that. On the quiz, you have to do a 4 theta case. So I just want to come in and out until I get one loop and go from there. So how do I do that? So let me show you that over here now. All right, so what I did was, okay, let me just start at 0. Plug in 0, cosine of 0 is 1, times 4 is 4. And then I said, well, since I have to multiply by 3, let me try pi over 6. Because 3 times pi over 6 is pi over 2. Cosine of pi over 2 is 0, so it comes into the pole at pi over 6. And then rather than keep going, you'll get a nice pattern. Okay? I just need to get one loop. If I keep going, it'll be a while until I get a loop. But then I said, well, why don't I pick negative pi over 6? Because negative pi over 6, and I know cosine's an even function, so negative pi over 6 should also give me 0, and it does. If you plug in negative pi over 6, you're taking the cosine of negative pi over 2, which is also 0. Okay, so I got one loop going from negative pi over 6 to positive pi over 6, and here is that one loop. And that's it. So I don't need anything else. So I didn't need to use one of my graph papers up for that. All right, so to find the area, I do have symmetry. So rather than integrating from negative pi over 6 to pi over 6, I would just go from 0 to pi over 6 and double it. The nice thing about that also is the formula already has a half, so I get to cancel the half. Okay, so the area is from negative pi over 6 to pi over 6 of 1/2 4 cosine 3 theta squared d theta. Take out the half, and then 2 times the integral from 0 to pi over 6. Right? Because I get to use a 0 now. So rather than going from negative pi over 6, that should be a pi over 6 too. So I'll just go from 0 to pi over 6 and double it. So what do I get when I square this? 4 squared is 16 cosine squared 3 theta. 16. Okay, cosine squared 3 theta is 1 plus cosine of double that angle divided by 2. So if I double this angle, I have 6 theta now. Okay, and 16 divided by 2 is 8. Integral of 1 d theta is theta. Integral of cosine 6 theta is sine 6 theta times 1/6. again, going backwards from the chain rule in Calc 1, right? When you get to this stage for differentiation, you would multiply by 6. Since I'm integrating, I divide by 6 or multiply by 1/6. And once again, this theme happens a lot. When you plug in 0, you get 0, 0, sine of 0 is 0. And then for pi over 6, this again gives me 0. 6 times pi over 6 is pi, sine of pi is 0. So the only thing of substance is plugging in the pi over 6. So the final answer is 4 pi over 3. Okay, then I want to mention 21. So I went over an introduction to this the other day because I knew it would be needed here. For 21, it says inner loop. Where is it? Problem 21. Yeah, r equals 1 plus 2 sine theta inner loop. Okay, so I showed you that the other day, something like that. There was an inner loop and an outer loop. Okay, so I had to know where this came into the pole by setting it equal to 0. So in other words, 1 plus 2 sine theta is 0. A little bit of algebra. Sine of theta is -1/2. So y coordinate is -1/2. That's here and here. Okay, so that looks like a reference angle of 30 degrees. That looks like a reference angle of 30 degrees. That's 7 pi over 6 and 11 pi over 6. And that would give me the inner loop. Okay, if you look back at what we did the other day, there was an inner loop and there's a much larger outer loop. Okay, so for the inner loop, I'm going from 7 pi over 6 to 11 pi over 6. Okay, so the setup would be area is integral from 7 pi over 6 to 11 pi over 6 of 1/2 r squared d theta. And I just say et cetera after that. You can work out the rest of that. Okay, so there was an inner loop. Okay, and then there was a much larger outer loop. Okay, as for the inner loop, it goes from 7 pi over 6 to pi over 6. So take out the half, square this, and then integrate from there. Okay. Okay, then 23. What do they want there? 23. Find the area of the region that lies inside the first curve and outside the second curve. Inside the first, outside the second. Okay, so how do you do that? Okay, so 23, it's actually 23 star. This is not quite what the text has, but it's similar. R equals 2 cosine theta, R equals 1. Okay, R equals 1, that means the radius is 1, circle. Okay, how do I do this one? Okay, so first I need to find out where the two graphs touch. We did that in Calc 1, did we not? Okay, so where do the graphs touch? Set them equal. So 2 cosine theta equals 1. Cosine theta is 1/2, i.e. x coordinate is 1/2. That gives me 60 degrees or pi over 3 and negative pi over 3. So they touch here and here. And now, how about the rest of the graph? Well, the only thing you need to know is this one inside or outside this one? So I need a nice angle between negative pi over 3 and pi over 3. Well, nice number between them is 0. Plug in 0. Cosine of 0 is 1. 1 times 2 is 2. So the trig function comes out to here, but r equals 1, of course, stays here. So I know that this one is the outside. So a very rough sketch is this thing. Okay, so it says inside the first curve, but outside the second. So I throw out this part. So this is kind of like the upper minus the lower that we did at the beginning of the semester, like the very first topic. You might recall we did something like this, right? F of x, g of x. If we wanted the area, I integrated f of x minus g of x, right? I did the integral of f of x minus g of x dx. So likewise here, it's the upper area minus the lower area. And yes, since I'm going from negative pi over 3 to pi over 3 with symmetry, I'll go from 0 to pi over 3. Okay, so at least at the beginning, negative pi over 3 to pi over 3, 1/2 bigger r squared, so 2 cosine theta squared, minus the smaller 1 squared, 1 squared. So it's 1/2 big R squared minus 1/2 little r squared. You take out the half, and instead of going from -π/3 to π/3 because of symmetry, I'll take a 2 out, which very conveniently cancels this, and go from 0 to π/3. And this thing comes out to be 4 cosine squared theta minus 1 d theta. Okay. So that pretty much does it. And cosine squared again. So 1 plus cosine 2 theta over 2. If you need to put this identity on your formula sheet, you may. Cosine squared, 1 plus cosine 2 theta over 2. Sine squared theta, exact same formula, except there's a minus here. And let's see, I canceled the 4 with a 2, so 2 times 1 plus cosine 2 theta. So I'm going to have 2 minus 1. Right here, 2 minus 1, so 1 plus 2 cosine 2 theta. Okay, so the integral of 1 is theta. Integral of cosine 2 cosine 2 theta is sine 2 theta. Double check by differentiation. Derivative of that is 1. Derivative of this is cosine 2 theta times 2 from 0 to π/3. Okay, 0 does give me 0. π/3 is a little bit clumsy. π/3 plus the sine of 2 π/3. Sine of 2 π/3 is radical 3 over 2. I mean, this is essentially the answer, but I got a common denominator of 6. So best final answer is 2 pi plus 3 radical 3 all over 6. Okay, then let's see. 27 was the last one I was going to do today. R equals 3 cosine theta, R equals 1 plus cosine theta. You don't need your graph paper for this. You just want something quick and dirty, tell you where we're going to integrate from. All right, so where do they touch? Set them equal. So 2 cosine theta is 1, cosine theta is 1/2. Well, we already did that last time. That's π/3 and negative π/3. Pick a nice number between them, like 0. Put a 0 here, R is 3. Put a 0 here, R is 2. Okay, so 3 cosine theta is the outside one. 1 plus cosine theta is the inside one. So the area that I want is here, upper minus lower. So 1/2 big R squared minus 1/2 little r squared. And again, because of symmetry, take the half out. Instead of going from negative π/3 to π/3, I'll go from 0 to π/3 and double it. And that pretty much does it. This gives me 9 cosine squared theta. If I square this, everything is positive. The minus in front means make everything negative. So -1, -2 cosine theta, minus cosine squared theta. So that comes out to be 8 cosine squared theta, -2 cosine theta, -1 d theta. And then I just said, et cetera, after that. You guys take it from there. That should be easy. That should be easy. There's that cosine squared again. So you know what to do. Change that to 1 plus cosine 2 theta over 2. And then do the rest of that integration. Okay. All right, so that's up to 27, which was what I was planning to do for today. Let's take a look at where we are. So I've done up to somewhere around here. So Monday, I'll knock off the rest of these 30, 31 star, reminder 31 star, I'm changing it. It's on page 673. Instead of r equals sine 2 theta and r equals cosine 2 theta, I change it, problem 31, to r equals sine theta and r equals cosine theta. A little bit easier. So don't look in the back of the book for the answer. It won't be the same as that because I changed the problem somewhat. Okay, so I'll do the rest of that on Monday. Then we have Tuesday, Wednesday, and maybe Thursday to knock off 10.5, which is an analytic geometry. And that'll lead us to the next exam, which is next Friday. Okay, but the rest of today, I'll let you ask questions, and if not, get started on that quiz that has the 4 theta involved that was there. Okay, so let me stop the share and see if anybody has any questions right now. Let me check the chat. Okay, any questions, please? All right, have a good day. Have a good weekend. Quiz is due by 11:59 p.m. It's long, but you should be able to figure it out. Okay, bye, everybody. Have a good day.
Thank you, Professor.
Thank you.